Right. So how did the assignment go? Anybody come up with funny monsters or whatever? What do you got? You lose who? And that's funny? What sport? Well, I guess that's funny to begin with. And so, did you do anything funny to your teammate's face or anything, or just your teammate? Okay. Anything else better than that? 'Cause I didn't think that was that great. Nothing? Well, did you come up with at least something better than my smiley face? I started thinking to myself how much better this would be for an actual iPhone app where you could tap with your fingers rather than having to move the mouse. Okay, so let's go back here, and we want to add a little bit more functionality in here. So right now we have this observer, and our observer is this guy who sits on the screen, and he's in charge. He's in charge of spawning these smiley actors. Okay? Now, what we might want to have is we might have, well, let me just back up for a second. The concept of an observer and how it relates to our games. And usually you wouldn't necessarily have an observer be visible like this. In this case, we're kind of giving him double purposes as also a scoreboard. But observers know everything that's happening in the scene. They have access to the scene. And I'll kind of give you a sneak preview of that here. If I double click on this guy, I'll just unlock him here for a second. If I, here we'll do change attribute. Now notice I double clicked on the guy that's actually in the scene. That is this particular instance of an observer. And notice he has one more thing than we had before. Before we had the game, we had devices, and we had this particular observer. Well, now we have this thing called the current scene. Okay, so the current scene has layers in it, background layers, the observer. That's who's currently in the scene when we begin with. But if we had other guys like Mario and stuff like that, we would see them line up here. So an observer that's actually in the scene would have access to make changes to other guys that are currently in the scene. Okay? So that's the advantage of having something in the game and being able to make changes to them. The disadvantage to that, and let me just go back for a second. Let's revert to the prototype. And let me show you the observer in here. If we were to add a change attribute in here, notice he only has these three. Okay, so we don't have access to the actual scene from here. So that's where the idea of an observer comes in terms of putting them on the screen and modifying this one guy rather than working with a prototype. Okay, because this one guy has a certain role to play. That makes sense? So what we're going to do is we have this first observer here, and I'm going to go ahead and I'm going to create a second observer. And we're going to go off script with this guy. So we're going to open that. We're going to get rid of the timer. We're going to get rid of the display text. Well, we'll have some display text. We'll get rid of this change attribute, which I don't know why we put that in there in the first place, but well, that was for my example. So we'll get rid of that here. Okay, so notice we have two different observers on the screen. This guy has the original crap from the blueprint. This guy has nothing in it. But we're going to start putting some stuff in it. What I'm going to do is at the game level, I'm going to create, actually, no, let's do this. Let's take advantage of our observers here. Kind of show you this example. So I'm going to go ahead and I'm going to double click on this. I'll unlock this guy here. So now this guy is no longer bound to the prototype. Okay. I'm going to go into our prototype and I'm just going to delete everything from our prototype. So this is as if we had created this prototype, left it empty, and then we drug him onto the screen twice. In this copy, he does this. In this copy, he's going to do something else. So we have this idea of a generic observer, where an observer is a dude who's part of our scene, and every observer kind of has a job to do. All right? So what I'm going to do is I'm going to go into this particular observer, and I'm going to create we need to do something a little different here. I'm going to make his name, let's call this guy Smiley Observer. Okay. And looks like I cannot create a attribute there. So I actually have to create the attributes here at the top level. So I'm going to go in here. I'm going to create, this is at our prototype level for all observers. I'm going to create a integer. We're going to call this guy num smileys, and it'll start off at 0. What we want to do is we want to keep track of the number of smileys on the screen. Make sense? So this observer right here, and notice he now has num smileys, which tells us that attributes are associated with blueprints, not with individual actors. So we can't have 2 instances of observers with different sets of attributes. The attributes are set at the global level. We can change them at this local level, but we have to set them. If we only need one guy to have an instance of this variable, we're going to have all the guys have an instance of this variable. So what we're going to have is every single time, well, let's go back in here. We're going to tell this guy to display some text. And what text is he going to display? He's going to display his own num smileys. And we'll put some text before that. We'll say spawned, colon, and then the dot dot. Okay, what does dot dot do for us? String concatenation. Talked about that last class. This idea of concatenation where we glue multiple things together. So 5 dot dot hello will give us 5 hello. So this kind of gives us a nice way of displaying an output. So this guy's going to display the text spawned colon and then a number, the number of things that were spawned. And I'll change the color to black since we have a white billboard here. All right, so this particular observer is just going to show the number of dudes that have been spawned. Actually, right now, he just displays all this guy does is he displays the current value of num smileys.
Oh, what's the syntax for spaces?
I was hoping I was going to be able to avoid that conversation. There isn't a syntax for spaces. So if you want to have spaces, which is what you want to do, we're going to do this. We're going to create another observer. And we will say this guy's going to be text. Actually, let's just do this at the top level. So he's shareable by all of them. So in our game, we're going to create in our game, we're going to create an attribute. And this attribute is going to be of type text. And we're going to name this guy the space. And he's going to be equal to a space. All right, so now what we can do is not in that observer, in this observer, we could say spawned concatenated with the game's the space variable concatenated with self num smileys. Does that make sense? So it's kind of like our ghetto way of pulling it off. I don't even know why that you can't put a space in there as part of strings, but it's just a thing. All right, so this observer is just always going to display the current value of num smileys, whatever that is. We're never actually changing that value right now. So it's always going to display a 0 in our current version of the game. So now you see we have the space there. So it's always 0 right now. What we'd like to happen is every single time this observer, every 1 second the timer spawns something new, we want to see the number spawned go up. Because what we want to see is how close are we to, how well are we doing catching up. Does that make sense? So we're going to have this observer. They're both instances of the original observer, but they each do very different things. That's what we did by going off script, by releasing them from the prototype. So every 1 second we'll spawn the actor. We will also change an attribute. What attribute are we going to change? We're going to change our current scenes, layers, background, smiley observer. Remember I gave him a little bit different name? Okay, smiley observer. We'll change his num smileys to be whatever it currently is +1. So notice that we're doing this at the scene level. We are accessing a particular instance of an object in our scene. And we do that through the layers variable in current scene. Num smileys +1. All right, so every 1 second we will increment that. Every 1 second we're going to increment. Every 1 second, this guy will increment this guy's version of the num smileys variable. This guy is constantly, through a persistent behavior, showing his version of num smileys. Make sense? So you see this now going up. And just as an example here, I'm going to double click on this, and instead of showing his version of num smileys, I'm going to say I'm going to show the current scenes, layers, the other guy's num smileys. And we'll see that this always stays 0. Because the other guy is changing this guy's num smileys. Right now, this guy is displaying the other guy's num smileys, showing that even though they have the same name, they are separate variables. So we've just undone the solution to our problem, essentially. Okay? But just showing how these two, because they're both in the scene, have access to each other. All right? And notice how important it was that we went into this guy. And let me just switch it back so I don't forget. We're going to go back to his own version of num smileys. Notice how important it was for me to change his name. Because if we had just left it observer, we'll just throw something out here, change attribute, we'll see it. And I wanted to change an attribute as part of the scene. Layers, background, both of them are called observer. So now through trial and error, we can probably figure out who is who, but it becomes easier just to give them a unique name so we can identify them. Kind of make sense? So this guy will be the smiley observer. And maybe this guy is the spawner observer. Okay. And just real quick before I go any farther, I'm going to change this back to just observer just for a second. So this is what used to be smiley observer. I'm going to go into this guy here. Notice that the code for this updated automatically. So when we did change the name of our observer, it went through and in all of our behaviors, it updated any time we mentioned that guy. So we don't need to worry about breaking our code by changing the name of one dude. And that's something called refactoring. So it's a computer science term called refactoring. A method for automatically changing all occurrences of, let's just say, well, all occurrences of something in a computer program. Now, the difference here would be if I opened up let's just go into a Java program here. Okay, so for example, it doesn't matter what this code is doing. We're writing a web server in another class. So we have a variable here named SS. Don't worry what he is. We use that variable down here. Okay, we're going to change SS here to blah. Notice it did not change here. So now it's pissed off at us. As opposed to if I switch this back to SS and I highlight it, and I right click and I come down here to refactor and I say I want to rename this guy. Now I can call him blah and notice it changed it every place else. So in a language like Java, using Eclipse as a tool, which is our IDE in Java. So this tool here, it's called Eclipse. Eclipse is like game salad for us. Okay. So by using the refactorability of that tool, we're able to name our variables whatever we want and then refactor them without having to worry about something breaking. Okay? But as a programmer, we need to remember to do that. We need to remember that by changing this, we need to use the refactoring engine rather than just change it. Otherwise, we are now going to be responsible for changing in all other locations. Game Salad does this for us. So automatic refactoring, it's helpful. Okay, I would say it's still not a bad idea to double check to make sure it did it in all places. I don't know that we can with 100% certainty guarantee that Game Salad won't make mistakes. If you remember back from the 150 class, there was probably a question posed, what percent of computer programs have bugs in them? And what was the answer? 99.999, whatever. But they all do. And even if your code, even if what you wrote didn't have the bug, something else is having to run your code. So if we use Java as the example, when I run my program in Java, I'm reliant on the people who wrote the Java virtual machine to execute my program. Well, the Java virtual machine is a complex piece of software. What are the chances that that has 0 bugs? There's like no chance. There's a bug in there, right? Somewhere. Now it's gone through several revisions, so the hope is that the obvious bugs, the major problems, have been weeded out. But do you still believe there's probably at least one bug still in there? Absolutely. There's going to be something. It would be highly unlikely for there not to be. And even if the Java virtual machine doesn't have a bug, it's written in terms of the API for the operating system. So either, so the virtual machine is ported for Windows, it's ported for the Mac, it's ported for Linux. Well, what are the chances that Windows has no bugs? What are the chances that the Mac OS has no bugs? That the Linux operating system has no bugs? See where we're going with this? So eventually you hit the top level where it's like, okay, does our hardware have no bugs? Well, hardware tends to be much simpler. Something I like to talk about in our architecture class is that building a piece of computer hardware, building like a hard drive or something like that, is like the hardware version of programming. Instead of writing lines of code that do something, you're soldering wires together and connecting things into transistors and things like this. A transistor in hardware is kind of like a method that does something, okay, in software. Well, when we connect all this stuff up, it's solving a problem. You apply electricity on one end, and as it flows through these circuits, a problem is being solved. So hardware is just physical computer programming. So does that mean it's also susceptible to bugs? Absolutely. And some of those bugs are then external factors, right? You might create a piece of hardware and maybe you did really good soldering points and stuff like that. Maybe even maybe even your solution has no bugs. But now you are still reliant on the individual pieces of that. So for instance, if in part of your hardware solution is a transistor, you are reliant on that transistor functioning because you didn't build that transistor. Well, even if you did, you still are reliant on that transistor functioning. At some point, you're dealing with something that has electricity going through it all the time, and there's heat concerns and all sorts of stuff like that. Eventually, it could break, right? And that has nothing to do with whether or not you had a bug in your solution. Now there was a physical, something physically broke in your solution. Kind of makes sense? So just keeps going up a level, a level, a level, a level. It's always going to be somebody's fault. But none of our programs can we say with any sort of confidence, are bug free. All right, so, and I would say with significantly less confidence that GameCell is bug free. It's been in beta for a while, and I don't even know, do they currently advertise it as beta? Yeah. We've been using this for, I think, at least 4 or 5 years. And still beta. So that's taking the Google approach to software releases. We'll keep it in beta forever until it's become adopted, and we can no longer reasonably, like, didn't Gmail just come out of beta like last year? Or the year before that? And I think Gmail has been around since early 2000s. So it was in beta for a decade, where people were using it for they were selling it to universities and stuff to use it as their email backend, but it was still a beta product. It's the Google way of doing things. Okay, so did we switch it back? Yeah, now we're this. This guy's changing. Oh, we changed it to observer. Come back in here. We want to rename this guy to Smiley observer. And then we can go back into the other guy and we should see that it has updated. It's been refactored to Smiley observer. Go ahead.
So you have access to the actors, individual actors in the scene, but do you have any way to access the attributes of actors that are newly spawned after the scene has been created?
We don't. Because there's no reason why they don't know about those, but programmatically we can't write it before it's on the screen. So what he's saying is if we go into this guy, well, any of the guys really, even though as the programmers we know that there's going to be smileys on the screen, right? We're going to be spawning them every 1 second. When we go in and we want to mess with something associated with a scene, we go to layers, we go to background, we see that the only 2 guys there are our observers, not our smileys, because they're not in the scene yet. So how could we write something in terms of something that's not there? It becomes kind of a chicken or the egg type of problem. I'm trying to think if there's a way we could pull it off. Go ahead.
Well, I was trying to follow you on the Windows game salad, and when I tried to change the attributes for the prototype, it took out all the attributes from my game board. And
From these 2?
yes, sir.
Okay.
Is there a way to?
Had you already hit the unlock thing?
Yes, sir.
Okay, you got to make sure you do that. You have to, when you go in there, when I first put one of these guys out here, and you double click on him, he is linked to the prototype until you do that. Does that make sense? All right, let me just real quick, I want to see at the game level, can we create an attribute text integer real? Yeah, I don't think that there's a, as far as I know, there isn't a way for us to deal with something after it's come into existence. You would have to create something that each of those guys checks on. So you would have to have like another observer that's on the scene at all times, and that observer might have a bunch of attributes or at least one attribute, and then you teach each smiley that gets spawned to check in with that guy. And if something's changed on him, then they do something. So kind of indirect communication. All right, so our current game, we're getting things spawned. We should be able to now keep up. We're seeing, oh, lost them. See, this would be so much better if it was tough. All right, we're currently, what, 2 behind? And those guys are off to the races. They're so far off the screen, we could probably wait for a while and they might come back, but that's just randomness where they keep pumping out one direction. Oh. All right, so obviously I'm an expert at this game. All right, so kind of giving us a little bit more practice with observer type stuff. All right, now what could we do to this game to make it a little bit more interesting? So for instance, we just saw that example where we had guys that spawned, but now they are off the screen, right? Never to come back. Well, as game players, wouldn't we like to be able to clean up the the game somehow? So what if we put into our smileys a timer? So first of all, our smiley has a question they ask: should I die? That's if we click on them. Then they'll destroy themselves and they'll change the game's count to be one bigger than that used to be because you've killed one. We also have a timer that says every 1 second, change your direction. I'm going to go, so this is the change direction timer. I'm going to add another timer now. And I'm going to say after 5 seconds, I'm going to change my attribute. So this guy's position on X to 0. Similarly, I'll change his position on Y to 0. And to be honest, I don't remember if this goes upper left-hand corner or center of the screen. We can check here in a second. It's bottom left-hand corner? Okay, so then we'll update these here in a second then. So bottom left-hand corner, so if we want it to go over and up, we're going to say X, let's go to 250. What's our games? Let me just put a guy right there in the center. Let's look at his position. Okay, so let's do 250 by 150. Oh, sorry. That's in our smileys. So for every 5 seconds, if a smiley is still alive, we're going to have him reposition himself to 250 by 150. So kind of recenter himself on the screen. He'll still be cooking. He'll still be zipping around and stuff like that, but at least it gives us an opportunity to change something. And that goes after 5 seconds as opposed to every 5 seconds. And let's look at the difference here. So if I say after 5 seconds, I want that to happen. Here's our game. So we're going to let one guy get off to the races. Let's actually, just so we know he came back, let's this will be fun. All right, guys who come back are spinning. That's what happens. When we bring them back, we start them spinning, letting us know. So This particular guy, we'll put him somewhere near the center-ish, and we'll start him spinning counterclockwise. So when we see the guy spinning, we'll know that he's... All right, but these are multiple guys that are coming back now, so that's why multiples are spinning. Now, that first guy, I promise you, he's gone. So we let it run long enough. Because after 5 seconds, we brought him back to the beginning, but that only fires one time, as opposed to saying if we want him to come back every 5 seconds. So we go in here. Every 5 seconds will have the side effect of waiting 5 seconds before it fires even the first time. Okay, it doesn't immediately fire and then fire again in 5 seconds. It will fire after this guy has been in existence for 5 seconds, and then every 5 seconds from that point forward. So this guarantees us that we never actually lose any of our dudes. Okay, they will come back. They'll get recentered. So I'm going to try to keep up. How come none of them spawn over there? Is that just bad coding? We're going to let this guy get... Oh. All right. Hold on. Did I lie to you? Did I lie to you? It looks like I did lie to you. They're not coming back. Which means that we need to say, after 5 seconds, do this, then every 5 seconds inside here. Rotate them. And spin them. So this waits. This blocks for 5 seconds. And then we start a 5 second timer where it keeps happening again and again. Where's my spinner? This guy spun a little bit. And this is related to what we talked about last class, where for as long as the timer goes, does he start spinning? And when the timer ends, everything inside there dies. So that's why some of these guys are only a little bit spun rather than spinning constantly. So if I want them to spin constantly, I need to move them out of that internal timer. So after 5 seconds, we'll start them spinning. And every 5 seconds, we'll center him. So now this should have him spinning all the time after 5 seconds. So let's see if we can catch up now with my awesome skill set. Oh my gosh. This was a touch interface. It'd be so much easier. I'm gonna have to start bringing in a phone to put this on. Oh my gosh. All right, it seems like we could potentially possibly catch up, right? Possibly. Oh, I'm only 14 behind. $13 behind. Oh, more now. Oh, come on. All right. See, hard game. And then as our levels go up, after every, maybe the guy starts spinning faster, right? So if every time, every 5 seconds, we want to change our guy's linear velocity, because right now we have it set where we are changing his linear velocity on x to a number between negative 250 and positive 250. That's directionally, right? So what if we, every 5 seconds, just double his linear velocity, but it's still happening every 1 second where they change their direction. So what? Well, let me ask you this. So every 1 second we have these evil smileys, and every 1 second they change their linear velocity to some number between negative 250 and positive 250. That's a speed, right? Now what if I want that speed to double every 5 seconds? We can no longer hard code in the 250 and the negative 250. What do we need to do? Every 5 seconds, I want these guys to effectively have the potential of doubling in speed. So after 5 seconds, I want this to be negative 500 to positive 500. Then I want it to be negative 1,000 to positive 1,000. Then negative 2,000 to positive 2,000. And then the speed of light. How would you pull that off?
Set 250 as a base attribute.
Okay? So we're going to add 2 attributes to our smileys. So come down here. This guy will be a integer. So we'll call this guy range low. Oh, sorry. We're going to start that off at negative 250. And it's going to be called range low. And then we'll add a second one, also of type integer, called range high. And he'll be 250. So every 5 seconds, we will put this guy back in the center of the screen, and then we're also going to change some attributes.
You can create another attribute called level, and then have that increment every 5 seconds, and then
So you know what level we're currently on in terms of how ridiculous it is.
well, that way you can actually use the same velocity randomizer.
Oh, and multiply it by level
Right.
instead of just double it every time.
Yeah.
Yeah, I got it. But for right now, let's just double it. So for right now, we're going to say that we're going to take this particular smiley's range low, and we're going to take that same value and set it equal to range low times 2. So that'll double it in speed on the negative. Similarly, I'll just change attribute out again. Range high will be range high times 2. All right. Then in our change attributes up here for change direction timer, instead of it being negative 250 to positive 250, we want it to be range low to range high. So smiley's range low to smileys, range high. Same thing down here. Range low to range high. All right. So now we're going to go ahead and we're going to just start it, and we'll just let them spawn. I won't even click on it. Hopefully these guys start moving. Yeah, that one was going pretty fast. Remember, it's a random number, so we're still having to generate a random number between those two. As our range gets bigger and bigger, we start seeing these guys fly pretty quick. Okay. All right. Now, that's maybe one little game, and we can, like you said, we can have a level and stuff like that. There was another game that I once played on iPhone. I don't think it's around anymore. And what would happen is your smileys, and let's go ahead and just make this guy stop spawning dudes. Okay, so he no longer spawns. Yeah, we'll just take all of these out for right now. And instead, what we're going to do is we're going to go ahead and put just one smiley out on the screen here. I'm going to get rid of all the stuff that he currently has in there. And we're going to create a timer. And let's have it be every 1 second. And let's see, do we have a translate? Sheet size. All right, so we're going to change this guy's size. I want to say let's do a growth rate by 1.25. I think that'll increase it by 25% every 1 second. And let's just see if this guy grows like we think he should be growing. Not 25%. It's definitely growing. 1.25 must mean what? 1.25%. So to grow by 25% be this. Looks right. I can't stop staring at his eyes. All right, so, and let's actually, well, 25 is fine for right now. We're also going to add a rule to this guy that says if this actor receives an event, overlaps or collides with another actor of type smiley, then what's going to happen? Well, we're going to go ahead and have him get destroyed for right now. And what we want to do is we want to see how the hitbox works. So I have this guy here, and I'll put another one out here. Good enough. Okay, so every second these guys go up in size. Now notice what's happened here. Did they die when we thought they should die? Go back in here and look at this. This says, if this actor overlaps or collides with another smiley, he should get destroyed. We would have expected death to occur right probably here. Now, we think that maybe one has died now, but we're not sure. Correct? Let's move them a little closer to each other. Check something here real quick. Because I expected them to die that time. It shouldn't make a difference. These things should all, this should be a persistent thing. Actor receives the event. Lines. It's actually kind of interesting. Let's try this after 1 second. Let's make this grow 100 times, 100%, so it'll double in size instead of it happening every single time. Okay, that's actually interesting. I think growth rate then. Take this timer out. So growth rate must be persistent. So I might want to just do this by hand then. So this isn't giving me the behavior that I was looking for. Change size. That's an action. It should only happen once. But it's got a rate, so it just continually changes in size, as opposed to if I say every 1 second like I had before. Every 1 second we're going to change this actor's get this done here in the last minute. His size by whatever it currently is times 1.25. Let's just do that for his width right now. And we still have the rule. Why aren't these guys killing each other? All right, well, we'll come back next time and find out why these guys aren't killing each other. Do I need to ask the rule and the timer? I shouldn't have to. Interesting.
I think maybe it's only observing position updates.
Yeah, it could be. But I would have thought their hitbox should change in size. Is that under graphics, maybe?
Maybe you could wait until they're overlapping in size, but then change the position by 1 to see if it then forces a check on that.
We're right, but how are we to determine that they're overlapping?
So just like after a couple seconds.
Oh, I got you. Just guesstimate when you think it would happen.
Yeah.
That's interesting.
Yeah, I can show you.